Close your eyes. Take a deep, slow breath. Imagine the deepest, darkest night you have ever seen. You are floating, weightless, completely free. We often look up at the twinkling stars and dream of reaching them. We imagine great, majestic ships gliding through the void. We imagine humanity spreading across the galaxy, planet by planet. It seems like only a matter of time. Just a few centuries of progress, right? But here is a beautiful, humbling paradox. The stars are calling us, yet they are locked away behind unbreakable cosmic walls. Tonight, we will explore why interstellar travel is impossible, not just for us, but even for the humans of the far distant future. Do not feel sadness as we uncover this. Let this truth bring you peace. Let the absolute boundaries of the universe wrap around you like a warm, comforting blanket. You are safe here. Let us drift together into the profound, quiet truth of the cosmos. Since the dawn of time, humanity has been a species of restless explorers. We crossed endless oceans. We climbed the highest, most unforgiving peaks. We even left our footprints in the grey, silent dust of the moon. We sent robotic eyes to the very edges of our solar system. Voyager 1 is out there right now, drifting in the freezing dark. Because of these magnificent triumphs, we naturally assume the stars are just the next logical step. Science fiction has trained our minds to expect it. We believe in warp drives. We believe in wormholes. We believe in freezing our bodies for thousand-year slumbers. But the universe does not care about our movies. The universe operates on strict, silent mathematics. To understand why we are forever grounded on our earthly island, we must first understand the true scale of our cosmic neighborhood. It is a scale so unbelievably vast, it crushes human intuition. Let us leave the atmosphere behind and look at the real numbers. Let us begin with the concept of scale, the sheer vastness of the void. We often picture the solar system as a cozy neighborhood. But imagine this illustration. If the Earth were the size of a single grain of sand, the Sun would be a golf ball sitting a few feet away. In this scale, where is the nearest star? It is not in the next room. It is not in the next town. That next grain of sand is hundreds of miles away. Between us and that star is nothing but cold, empty, terrifyingly beautiful silence. This is the first wall, the wall of distance. But what about our closest neighbor, Alpha Centauri, specifically Proxima Centauri? It is only 4.24 light-years away. It is time to shatter a common myth, the myth that this is just a quick cosmic hop. 4 light-years sounds like a small number, but a light-year is not a measure of time. It is a measure of distance. It is the distance light travels in 1 year. Light moves at 186,000 miles per second. At that unimaginable speed, it still takes over 4 years to reach us. The distance is 25 trillion miles, a number so large the human brain simply cannot visualize it. Let us look at our fastest current technology, the Voyager probes. They are moving at over 38,000 miles per hour. Faster than a speeding bullet, faster than any earthly machine. If we point Voyager toward Proxima Centauri, how long would it take? Imagine a snail trying to cross the entire planet Earth. That is our illustration. It would take Voyager over 70,000 years to reach that nearest star. 70,000 years of darkness. Human civilization is barely 10,000 years old. Our fastest ships are practically frozen in place when compared to the galaxy. You might be thinking, we just need faster engines. But here is the absolute boundary, the speed of light. Albert Einstein gave us the cosmic speed limit. Many believe the myth that one day we will just invent an engine that breaks this barrier. But the speed of light is not like the sound barrier. It is not an engineering problem. It is the fundamental fabric of reality. Nothing with mass can ever reach the speed of light. As you accelerate, the universe pushes back. It is a law as unbreakable as the flow of time itself. Why does the universe push back? It is because of mass and energy. E equals mc squared. As an object moves faster, its mass effectively increases. Imagine pushing a small stone. Now imagine that stone turning into a massive boulder as you push it faster. Then it turns into a mountain. To push that mountain, you need infinite energy. To accelerate a single human being to the speed of light would require more energy than exists in the entire universe. It is physically, mathematically, and beautifully impossible. So, we must travel slower than light. Let us say we want to reach 10% of light speed. What about the fuel? This brings us to the tyranny of the rocket equation. To carry fuel, you need more fuel to push the fuel you are carrying. Imagine this illustration. To send a ship the size of a school bus to Alpha Centauri using chemical rockets, you would need a fuel tank larger than the observable universe. It is a mathematical trap. Every ounce of fuel works against you. The void demands a toll we cannot pay. Perhaps we could use the ultimate fuel. Antimatter. When antimatter meets regular matter, it releases pure energy. It is a popular science fiction trope. The myth is that we can easily harvest or create it in the future, but creating antimatter takes more energy than you get out of it. We have created only tiny fractions of a gram in our giant colliders. To power a starship, you would need tons of it. Containing it is another nightmare. If a single atom of antimatter touches the walls of its container, it explodes. It is a volatile, impossible dream. Let us imagine we solve the fuel problem. We are flying at 10% the speed of light. Now we face a new, invisible terror, cosmic dust. Space is mostly empty, but not perfectly empty. There are stray atoms. There are grains of sand. At that extreme speed, a simple grain of sand hits your ship with the force of a nuclear bomb. Imagine this vivid illustration, flying through a gentle snowstorm, but every snowflake is a cannonball. How do you shield a ship from a million atomic explosions every second? The faster you go, the more the universe tries to tear you apart. Beyond the dust, there is something more insidious: radiation. Deep space is flooded with cosmic rays, high-energy particles ejected from dying stars and black holes. Here on Earth, our magnetic field protects us. It is our quiet guardian. In the void, there is no protection. Imagine invisible, microscopic needles piercing your ship, piercing your cells, piercing your DNA. To block this radiation, you need walls of lead or water meters thick. That adds immense weight, which, as we learned, ruins the fuel equation. The universe is hostile to soft biological life. This leads us to the frailty of the human body. We evolved on Earth. We are sculpted by its specific gravity. When we leave it, our bodies begin to break down. The myth is that artificial gravity via spinning ships solves everything. But zero gravity, or even simulated gravity, confuses our biology. Fluid shifts to the head, vision degrades, the heart forgets how to pump hard. Our bodies are perfectly tuned instruments for this planet only. Take the instrument into the void, and it slowly loses its harmony. Focus on the bones and muscles. Without the constant, comforting pull of Earth pulling us down, our bones think they are no longer needed. They dissolve. They become brittle. Imagine your bones slowly turning to delicate glass. Astronauts on the space station lose bone mass even with rigorous exercise. On a journey taking decades or centuries, human skeletons would become too fragile to survive any eventual landing. We belong to the Earth. She holds us down because she is keeping us whole. Because the journey takes so long, we must consider the generation ship, a giant vessel where people live, reproduce, and die, so their great-grandchildren can reach the stars. The myth here is that life would proceed normally, just in a metal tube. But think of the reality. The people who arrive will not be the people who left. The original dreamers will die in the dark. The descendants will never have seen a blue sky, felt a breeze, or touched real soil. They will be prisoners of an ancient choice they never made. On a generation ship, population size becomes a deadly puzzle. You need a large enough gene pool to prevent genetic bottlenecks, but you cannot have too many people, or you run out of air and food. Imagine a tiny village, sealed inside a submarine, forever. There is no leaving, there is no new blood. One viral mutation, one genetic flaw, and the entire society crumbles. The mathematics of genetics are just as unforgiving as the mathematics of astrophysics. Biology demands a wide, open world to thrive. Then comes the psychological toll. The human mind needs horizons. We need the changing of seasons. We need the unpredictable beauty of nature. On a starship, every day is exactly the same. The walls never change. The hum of the engines never stops. Imagine staring out a window into an absolute, infinite black abyss. knowing there is nothing out there for trillions of miles. The terror of the void would slowly poison the mind. We are creatures of sunlight and wind, not creatures of the deep dark. But what happens to the connection with home? As a ship travels further away, Earth becomes just another pale star. Then it vanishes entirely. The travelers would lose all connection to their humanity. They would no longer be Earthlings. They would become an alien culture. The history, the art, the struggles of Earth would mean nothing to them. They would be orphans of the cosmos, drifting without a true home, searching for a planet they may never find. Let us shift to the machines keeping them alive. Technological decay is inevitable. Nothing lasts forever. Parts wear out, metal fatigues, electronics fail. Imagine a beautifully intricate clockwork mechanism, left alone in the dark for 1,000 years. It will eventually rust and stop. On a generation ship, you must manufacture every single spare part from the limited materials you brought. When the machines that make the machines break down, the end is near. Entropy always wins. The universe prefers chaos over order. To survive, the ship must be a perfect closed-loop ecosystem. Every drop of water, every breath of air, every piece of waste must be recycled perfectly. The myth is that 100% efficiency is possible, but thermodynamics forbids this. There is always a loss, a tiny leak in an airlock, a chemical reaction that binds oxygen forever. Over centuries, these microscopic losses add up. The air gets thinner, the water gets scarcer, the ship slowly, quietly suffocates. It is a slow, dying breath in the dark. What if we could go incredibly fast, close to the speed of light? Now we face Einstein's cruelest joke, time dilation. The faster you move through space, the slower you move through time. If a crew travels at 99% of light speed to a star 20 light-years away, they might age only a few years. But imagine this illustration. When they return, decades or centuries will have passed on Earth. Everyone they loved is gone. The society they knew is dust. They would return as ghosts to a world that no longer remembers them. Even communication becomes an agonizing weight. If a ship goes to Alpha Centauri, a simple message like "we arrived" takes over 4 years to reach Earth. The reply takes another 4 years. Imagine shouting a single word across a vast, dark canyon and having to wait almost a decade to hear the echo. You cannot have a conversation. You cannot ask for immediate help. The ship is entirely, completely alone. Silence is the only true language of deep space. There is also the paradox of waiting, the weight calculation paradox. Let us say we launch our best ship today. It will take 10,000 years to reach a star, but in 100 years, human technology advances. We build a faster ship. That second ship takes only 1,000 years. It arrives first. By the time the original crew arrives, they find a fully developed civilization waiting for them, looking at their ship as an ancient museum piece. It implies we should never launch, always waiting for better tech, a paralyzing cosmic joke. Many dream of cryosleep, freezing the body to wake up in the future. The myth is that it is just like going to sleep. But human cells are mostly water. Imagine this illustration. When water freezes, it expands. It forms sharp ice crystals. Like putting a glass bottle of water in the freezer, it shatters. The ice crystals tear the delicate cell walls apart from the inside out. We do not know how to freeze and thaw complex mammalian brains without turning them into mush. Death is not a pause button. It is a final destination. Navigating the dark is another profound challenge. When traveling at immense speeds, your field of view changes. Starlight shifts into invisible spectrums due to the Doppler effect. The universe ahead becomes a blinding wash of dangerous radiation, while the universe behind goes completely dark. You cannot see where you are going. Course correction at a fraction of light speed requires decades of advanced calculation. If you miss your target by a fraction of a degree, you fly into the endless void forever, with no fuel to turn back. Before we even leave our solar system, we must cross the Oort cloud, a massive spherical shell of icy debris surrounding our sun. It stretches halfway to the next star. It is a chaotic minefield. Imagine billions of icy phantoms, comets and rocks drifting in the dark. We cannot map them all. They are too cold, too dark. Flying a fragile ship through this unpredictable storm of ancient ice at high speed is a game of cosmic roulette. The outer gates of our home are heavily guarded. We must also talk about heat. Thermodynamics in space is tricky. Space is cold, yes, but it is also a vacuum. A vacuum is a perfect insulator. It does not conduct heat away. If you have a massive engine generating the power of a small sun to push your ship, where does the heat go? Imagine a starship slowly melting from the inside out because its own engines are cooking it. Without air or water to carry the heat away, complex radiators the size of cities are needed. More mass, more fuel. The trap closes again. Let us bring it down to Earth. The economic impossibility. The cost of a single interstellar mission would dwarf the entire global economy. The myth is that one day humanity will put aside all differences and unite to fund this grand vision. But taking trillions of dollars away from earthly problems, hunger, disease, climate, to send a handful of people into the void is a choice humanity may never make. The gravity of our earthly needs will always outweigh the distant call of the stars. We also underestimate the fragility of our biosphere. We do not live alone. We survive because of trillions of microbes, fungi, and invisible processes. We need the soil, we need the insects. To survive on a ship or a dead planet, we cannot just bring seeds. We must bring a perfectly balanced, microscopic forest. Imagine trying to pack the entire complexity of the Amazon rainforest into a metal tin. If one crucial microbe dies out on the journey, the entire artificial ecosystem collapses. We are tethered to the dirt of Earth. What about the exotic physics? Wormholes, warp drives, folding space. It is beautiful math on a chalkboard. The myth is that math automatically equals engineering. But the energy required to bend space-time is exotic. It requires negative mass, something that has never been proven to exist. Imagine trying to bend a sheet of paper to make two dots touch. Now imagine trying to bend the fabric of reality itself. It is a mathematical fantasy that provides comfort, but offers no real steel, no real engines. This impossibility beautifully answers a dark question, the Fermi paradox. If the universe is so vast and old, where is everyone? Why do we see no aliens? The answer might be the very impossibility we are discussing. The great filter. The distances are simply too great. The speed limit is too strict. Perhaps millions of civilizations exist, but they are all trapped on their own beautiful islands just like us, staring at the sky, sending silent radio waves into the void, unable to cross the vast oceans of night. As we accept these unbreakable rules, something wonderful happens. The anxiety fades. The desperate need to escape our planet dissolves. We begin to look at our earthly island with new eyes. We are not trapped, we are protected. The infinite, deadly void is kept at bay by our atmosphere. The crushing radiation is blocked by our magnetic field. The distances keep out cosmic predators. The impossibility of leaving means we must focus on preserving the paradise we already have. The boundary of the speed of light, the vastness of the distances, they are not a prison. They are the walls of a grand, beautiful garden. Imagine a walled garden floating in a terrifying, freezing ocean. You would not try to swim in the freezing ocean. You would tend to the garden. You would plant trees. You would make peace. The impossibility of interstellar travel is the universe telling us, here is your home. It is perfect. It is rare. Cherish it. Breathe in the air of Earth and know you are exactly where you are meant to be. We have traveled so far in our minds tonight. We have touched the insurmountable, invisible walls of our cosmic cage. But I hope you do not feel trapped. I hope you feel deeply embraced. The impossibility of interstellar travel is not a tragedy of science. It is a beautiful, calming reminder of how precious our Earth truly is. This pale blue dot is our only sanctuary in the freezing, endless dark. We do not need to conquer the stars to find meaning. The universe is right here, in the sound of the wind, in the warmth of the sun, and within us. Thank you for taking this quiet, cosmic journey into the unknown with me. As you drift into a peaceful rest, letting the vastness of space shrink your worries to nothing, I leave you with this question. If you could view any planet in our own beautiful solar system through a telescope right now. Which one would you choose? Sleep well, stargazers.